Hello, welcome everybody. This is a session called Big Data and Small Code, and it's all about using Java 8 and Apache Crunch to quickly develop concise, efficient, and testable data pipelines. I'm going to tell you a little bit about Apache Crunch. I'm going to tell you a bit about the new crunch-lambda module. I'm going to give you some real-world code examples from how we're using it at SoundCloud and the impact that's had on the teams, and then talk a little bit about the future at the end. But before we get on to all of that, let me just quickly introduce myself. My name's David Whiting, that's me there. I've been working with Hadoop and big data for about 5 years now, first at Last.fm, then at Spotify, now at SoundCloud in Berlin. So you might be able to see a theme in the kind of companies I've been working for. As well as my normal day-to-day jobs, I've got a special interest in improving the developer experience for big data, like to make it as easy as possible to pragmatically deliver the data that people need. I'm a committer on the Apache Crunch project, so that's my full disclosure there. And I'm also a music producer and artist, so you can go to there if you want to hear stuff. If you want to get in contact with me, devw@apache.org or @DAWhiting. You can tweet abuse or comments and criticism afterwards. So let's look at the state of the big data world in 2016. If you go to a lot of these conferences, you hear a lot of hype about new technologies, new execution platforms, new ways of doing things, new APIs. You hear a lot about Spark, you hear about machine learning, you hear about real-time stream processing, you hear about these weird advanced visualization techniques, and especially now, I think the trend at this conference is probably going to be about event sourcing and doing everything from an event-based point of view. But if you actually talk to the people who are working in organizations which are doing this kind of thing, doing big data, you'll find a lot of them are actually just using MapReduce to run ETL, aggregation, and analytics jobs as they always have been. There's a huge wealth of code and legacy and infrastructure that was all built for Hadoop MapReduce. And people aren't going to throw that away in a second when the new technology comes along. Or at least it's not very sensible to throw that away when the new technology comes along. So in short, and apologies if in the audience is a person whose talk is called this, but I wrote this slide before I knew this. There's another talk called MapReduce is Not Dead tomorrow. But yeah, this is my point here is that MapReduce is not dead. It's still being used in all kinds of organizations. It still works. So let's try and make it better. So in my role in data infrastructure at SoundCloud, I'm working with what you might call the boring end of the data pipeline. So we're not doing fancy analytics. We're not doing fancy machine learning. We're preparing the data for all those teams to be able to do what they need to do. So we're filtering out any bad data that might have come from the clients. We're transforming data that might be in different formats. So we have some clients that might emit some JSON in some old schema because that client, we can't update it anymore. It's out in the world. We also might have some new client or some server emitting the new protobuf data. And we need to consolidate all that into the same format so we can process it downstream. We also need to split the data, take all the data of all the different event types and the time when it happens and split it into buckets by the type of event it is and the time it happened. So that means when people are processing the data later, they can just read a directory on HDFS and not have to pre-filter everything, read too much and throw most of it away. We have some correlation jobs so we can correlate related events. So for example, if someone on SoundCloud starts listening to a track, and then they seek to another part of the track, and then rewind, and then carry on playing. We want to see all those events as one view. So we have some jobs to stack up events on top of each other, because we want to process them as one unit. We also have some monitoring workloads, monitoring the counts of events and the types of events we're getting, because that's a really good sign that something might have gone wrong if we see big spikes or dips in the counts. And then some simple pre-aggregation jobs which feed into analytics or other databases like Cassandra, that kind of thing. But we have a problem. All of this stuff is written in MapReduce, or at least it was 6 months ago. But the MapReduce API hasn't dated very well. It hasn't aged very well since about 10 years or something. It's been around, maybe more. The rest of the way we interact with data has moved on a lot since then. And if you're still writing code against the original MapReduce API, you're probably getting a bit frustrated with how much you have to do, which is where Apache Crunch comes in. Apache Crunch is an attempt to make that developer experience for MapReduce a whole lot better and more modern. So I'm going to take a quote from the Apache Crunch webpage because it explains it better than I can. And that's that the Apache Crunch Java library provides a framework for writing, testing, and running MapReduce pipelines. Its goal is to make pipelines which are composed of many user-defined functions, simple to write, easy to test, and efficient to run. So in practice, that means it's functional. You express everything as a series of functional transformations. It's type safe rather than field-spaced, as many other products in this space are. So that means it's particularly well suited for the boring end of the pipeline when you're dealing with big structured records that you have to propagate intact and you can't deal with any mismatch in that data, and you have a strict schema to adhere to. Everything runs as MapReduce. There's no extra software you have to install on your Hadoop cluster. You just build it against Crunch, and that gives you a jar you can run with Hadoop jar or Yarn jar on your cluster. There is a zero boilerplate requirement unless you're doing anything particularly fancy. None of that setup and configuration and that whole ceremony about writing MapReduce jobs applies. It also has switchable implementation, which runs in memory. So that makes it really easy to run unit tests of your pipelines. And also, the way you construct your pipelines is comprised of standard Java functions. So if you want to do low-level unit testing, you're just testing normal functions. And it's used at despite not being the coolest or the most trendy thing, it's actually used at a surprising number of major organizations. We're using it at SoundCloud. Before I used it at Spotify. It's used at Cerner. It's used at a whole host of companies that don't really speak publicly about the stuff they're doing. So I can't tell you what they are, but I've spoken to people who work there who use Crunch. So it's pretty stable and it's pretty usable. So the basic approach behind Crunch should be familiar to anyone who's seen any of the more modern APIs for developing with data. And that's that each data set, as you read it, or as you, in every stage of processing, is an immutable, lazily evaluated collection of records. So you take a collection, and then you apply a transformation, you get another collection, you apply a transformation, you get another collection. And at some point, when you're done, you write it to HDFS, and that's when the whole thing gets evaluated. A query planner comes along and turns it into MapReduce jobs, and then runs the jobs, writes everything out to HDFS. So if you're familiar with Spark and RDDs, a Spark RDD is sort of like a Crunch P collection. And the API, I'm not sure why I've written Java 8 Stream API. It's not quite relevant to this bit. It's relevant to the next bit. Never mind. So still 10 years on, Hadoop, everyone likes to see this example. It's mostly a tool for counting words. So in Crunch land, it looks a little bit like this. So from the top, this is the whole code, by the way. If you put this in a public static void main, then put it in a jar, it'll run as a MapReduce job on the cluster. So we're reading from a text file on HDFS. Then we have this parallel do function, which takes each line of text. We split it by space, iterate through the words in the line, emit the word as the record to output. Then this built-in count function counts the number of instances of each word. Then we have another parallel do thing, which takes the pair of strings and longs, so that's the word and the count, and formats it for output by just here, taking the word, colon, count. Then we write to the text file, and then we write crunch done. That means it's going to do all the query planning and the execution, and run your jobs, write everything to HDFS. Now, this is already a big improvement on working with the normal MapReduce API. We haven't had to do any mappers and reducers and implementing classes and passing class names to everything. But there's still a lot of noise here. There's still a lot of redundant information. If you can see when we're doing these do-fns and these map-fns, we're expressing the type information of the inputs and the outputs at least 3 times in each of those. And that's too many. And also, it hinders readability if you're trying to parse all of this and you've got all this extra noise around the anonymous inner classes in the way. Because actually what we're really interested in is this, which is a whole lot less information and a whole lot easier to read. Now, luckily for us, Java 8 is out, and now means that we don't have to do this whole ceremony of anonymous inner classes if we want to pass around functions that we've defined at the call site. So in about late last year, about October, November time, we at SoundCloud upgraded our Hadoop cluster to the next version along, and in the process, we also upgraded to Java 8, and that gives us the ability to run Java 8 stuff on our Hadoop cluster. I don't think it's officially supported by Hadoop yet, but we've been running it on Cloudera's CDH5 with no problems. So it seems to be pretty stable for us. But the trouble was there was no compatible Java 8 API for using with Crunch. And because Crunch is still very much based on abstract classes rather than interfaces, there is no drop-in replacement for it. So in January of this year, I wrote a new API for Crunch based on Java 8 called crunch-lambda. And the idea behind it was to take advantage of all Java 8's features in method references and lambda expressions and the streams API, and wrap Crunch in that so you can interact with it in a way that feels as native to Java 8 as possible. So that means we work with streams instead of iterators and iterables, and all those logic that we saw expressed as these do-fns and map-fns are now just lambda expressions or method references. So as of last month, that is now in the main Crunch release, 0.14.0, and ready for use, and it works pretty well, and we're using it at SoundCloud. So if you take the example I just gave you and put that into crunch-lambda world, it looks a little bit like this. Now, the first thing you can notice about this is there's a lot less code. But the second thing, I'm not one to cut down code volume arbitrarily if it's not saving anything. But the most important thing about this is I think it's a lot more intuitive and easy to read. You can follow the structure of the program a lot more easily. You see, we're reading from the text line, we're taking each line, we're splitting it by space, but instead of doing this in a pair of input and emit, we're doing a flat map, which is usually a bit more intuitive for people to think about as a transformation from one record to 0 or more records. We do a count operation, and then we're mapping them to the same format as before, writing out to the text file. And the only thing that's different about this in terms of using the API is we've wrapped the original collection we read from the data in this lambda.wrap. So that's crunch-lambda. It's fairly simple. It's a really lightweight wrapper, so it uses all the Crunch execution underneath. In order to understand a bit more about Crunch, it helps to look a little bit at the data model behind it. So in the world of Crunch, there's 3 types of collection. There's a P collection, a P table, and a P group table. In a P collection, you're just looking at individual records of data. So that could be a string if it was lines of text in a file, or it could be numbers if you've got some numeric data set to process. In our case, it's most often structured records, so we have all of our event data stored as protobufs in sequence files on HDFS. So when we have a collection of things, it's usually a collection of some event type. But the important distinction between that and other types is that, according to Crunch, it doesn't know about the structure of the data, it just knows that you have one event. So in the table representation, you can go from in the table representation, Crunch knows about a separate key part and a value part of each record. So here you might take your structured record and extract a key from it to create a key part of the record as well. Or you might be reading data from HDFS in, for example, a sequence file, which has a key and a value part already. So that's naturally represented as a table. So in this example, you can see that some of the value rows share the same key, and some of them have different keys. So when we take the table, when we group by key, we go to a group table, and that's where we collect together all the values for each unique key. So if you do a transformation from a table to a group table, and then back to a collection or a table, that pretty much in all cases gets run as a MapReduce cycle. So when you go from the table to the group table, that's when you're going from the map side to the reduce side, if it helps you to think about in terms of MapReduce originally. So with those 3 types, I'm going to show you another slide that everyone tells me I should remove from this presentation because it's confusing and there's arrows everywhere. But we're actually missing the left part of it as well. But this is just showing you the different transformations between the collections and how you get from one to the other. So we can read in data and get a collection or a table. And when we have a table with a key and a value, we can group by key to go to a group table. And then in group table, you see all these operations for aggregating values by key. So we have ways to combine them, or providing a reduce function, or collect them into a collection, or do some other kind of custom processing. So that's all well and good, and seems sensible, but what if we're not running a word count company? It's quite often in these kind of talks to give a couple of toy examples and then say, here you go, off you go, run with it, without any examples from the real world. So I'm going to take you through a couple of examples on how we're using Crunch right now in SoundCloud to do one simple workload and one more complex workload. So the first example I'm going to talk to you about is all about monitoring event counts. So as I mentioned before, it's really useful to monitor the counts of events as they come through, to look for anomalies that might be happening in the clients or anomalies that might be happening in our transport, our event transport system. A quite common case is that someone pushes out a new client and they don't tell us about it, and they've slightly changed the schema, so they're emitting a string when they used to be emitting an int or something, and then the count for that massively drops because we can't parse it in our system. So it's really useful to monitor counts over time. And one thing we do is just count events by the type of event. So that might be sound played, or user clicked a like button, or something like that. And applications, that would be like iOS, Android, web, something like that. So we do that by using a metrics system called Prometheus. If you don't know about it, it's a really good way of tracking metrics and doing alerts for your services and things. It's another open source project that came out of SoundCloud. So if you want to know more about Prometheus, just as an aside, go to prometheus.io. It's grown way beyond SoundCloud now, and it's a big thing. But here we're going to use the push gateway, which is a way of pushing metrics at Prometheus, where Prometheus is normally a pull system. So you push it to the push gateway, it hangs around on there for the Prometheus scraper to come around and scrape the metrics. So we create the Crunch pipeline using the MapReduce implementation, create a push gateway client which is just an HTTP endpoint that we push the metrics at. This gauge thing is a thing from Prometheus, so we're creating a gauge with event count as the metric and two labels, which is the event type in the application. So sound played and iOS, for example. We create that gauge, and then we read the events into a table. This read events function is a little bit more complex than just read from text file or something, so I factor that into a function. I'm not showing that here, but when we've done that, we have a collection of key value pairs in the table, which is a long timestamp and a structured protobuf event type. But we're not interested in the timestamp, because in the read process, we are already bucketing it by time. So we throw away the key part, which is what this values thing does. And then we map it through just a plain old Java function, which is creating this stats key object from the event. And that stats key is just comprised of the event type and application. In the real world, there's actually a few more fields in there, which is why I justify having a separate type for it, but I've slightly simplified it for this. And then again, just like the word count example, we're counting the number of events for each stats key. Then we use this materialize function, and the materialize function is a really powerful feature of the Crunch abstraction. What materialize does is write out the results at that point to a file. So it will run the MapReduce job, write to a file on HDFS, and then open the file for reading and give you a pointer into the data locally from where you're running the job. So all of this, the map and the count, has been run on the Hadoop cluster. And then when we use materialize, we're bringing that data locally and running some more code with it. So it gives us a Java 8 stream of those stats key and count pairs. So then when we have all that data locally, we can just iterate over it in this application itself. So that's the stream style for each here. We take the stats record, apply the labels to the gauge, and set the count. And then finally, at the end of it, we can push all the metrics to the Prometheus push gateway. And then on the Prometheus push gateway, we set up graphs, and we can set up alerting rules. So if any of these keys is much higher or much lower than it was yesterday or last week, then we can fire off alerts, wake someone up in the middle of the night, or something like that. So that's a really simple use case for how we're using it in our event transport and delivery pipeline as a just kind of last check. Very simple check, but it also helps us notice a lot of failures earlier than we ordinarily would. So the second example I'm going to take you through, is about a user-facing product, and that's the SoundCloud Stats product. If you're a creator on SoundCloud, I don't know is anyone here a creator on SoundCloud? No, okay. So we got one at the back. So if you're an artist on SoundCloud, a sound creator, then you have access to a stats product which gives you feedback about how people are listening to your sounds. So this is mine for one of my artist pages. So you can see all kinds of data about when people have listened to me, how many plays, how many likes, how many comments. But in the bottom half of this, you see some top lists explaining different dimensions. So we have the most played tracks by this artist. We have the countries in which the tracks by this artist are played the most. We have which users are listening to the artist most. And we have which websites they get to your page from. So it's all about giving sound creators a bit of insight into how people are listening, and maybe like if you see one country spiking, then you might think, okay, now I should try and engage listeners in that country. Or if you see one track that you're not expecting to be popular is more popular than all the rest of your tracks, maybe it's time to investigate why and see if you can do something with it. So it's really powerful data for the creators to use. And the back end for this is implemented, again, as a crunch pipeline. So this is the main part of the code for this. Before this, there's a little bit that reads the events, and at the end of this, there's a part of it which takes all the output data and formats into records which get loaded into Cassandra. We actually create the SS tables and push them from the MapReduce job itself. But I've left that bit out because I want to talk about the processing steps. So this is a little bit more of a complex example. It's going to manifest as two separate MapReduce cycles, but let's go through it step by step. So we have an event stream of events that happen somewhere in SoundCloud. So here we have an example. Sound played, so the sound has been played by David, that's me, in Germany on the web client. Now, there's a function called create facts from event that generates some one or more facts from that event. So in this case, there's 3 facts that come from that event. One is that the sound has been played in Germany. The next fact is that the sound has been played on the web client. And the next fact is that the sound has been played by the user David. And we emit what's called a bucket is the key part of this, and a value of 1 for each one of those. So we're deriving like more than one piece of information from each event that comes in. And then we have other event types like sound favorited or reposted or something like that. Then we group those by key and we sum up all the counts so we can see that this track was played in Germany twice, for example, with that input data of 2 records for the Germany bucket and 1 record for the UK bucket. And then after we've summed up those counts, so when we do this reduce values, that's when it will happen on the reduce side of the MapReduce. We also need to filter the values because some events can generate negative facts. So if someone unfollows someone or unfavorites something, it can create a negative count. And it turns out if you present the data to users with negative favorites or negative reposts, then they're not so happy about it. So we filter out the negative counts because the users don't like seeing those. And then we move on to the next step. And the next step is about we have to shuffle the key and the value parts of the record. So when it used to be a bucket play country Germany 2, what we're now interested in is aggregating things by the column in that top list view that I showed you earlier. That will be the heading for the top list. So here, this is the top countries that this track is played in, and then the value is a top list pair of Germany and 2. Because the idea is we want to collect all those values together and keep the top K of those. So once we've shuffled the key and value part, which is just this remap dimension keys, just takes one thing out of one record and builds this new pair of these 2 parts of the record. Then again, we do a group by key, and that gives us a group table, and then we can operate on the value part of this. And this map values function will just give you a pair of the key and a stream of the values and excuse me, give you a pair of the key and a stream of the values, and then you can return some kind of record. So here we're using a plain old Java streaming top k algorithm, which is this, find top k. So we just create a sorted set with a comparator of the count reversed. So we want the biggest ones at the top. And then we compare also by the dimension value, which is like the country name, because we want to keep this deterministic. If we run it again, we want to have the same output. And then for every input, we add it to the set, evict stuff if it gets bigger than k, because k in this case is something like 50. So this is a perfectly sensible way of doing it. So since we've been changing things around to use Crunch at SoundCloud, when I turned up at SoundCloud about 8 or 9 months ago, we had a lot of old MapReduce code using both the original MapReduce API and some custom in-house abstraction over it, which didn't really help very much. It's had quite an impact at SoundCloud. So we see a lot of these complex MapReduce job graphs replaced with simple pipelines, which are easy to read, they're easy to understand. Another developer can come and pick it up, read it, understand what it does, make modifications to it. So just in my team, as well as those two, we have the entire event cleanup and splitting, and that part of the pipeline is all in Crunch now. And we have the job that takes related events and stacks them up, events related to sounds being played and stacks them up so we can get an accurate idea of the duration that someone has been listening to a sound for. That also happens in Crunch now. We have 4 different teams using it. We have our team in the data infrastructure. We have the insights team, the royalties and reporting team delivering their reports to the record labels, and also the trust, security, and safety team are doing some of their analysis using it. And all of them are saying that they're much happier using this than MapReduce. We've even had some people that were writing stuff in Spark change to using Crunch because the execution is a little bit more reliable and it doesn't use so much memory on the cluster. So especially if you have a really big data set, Spark can sometimes be a bit iffy with that when you're spinning to disk. So people who were using Spark are now using Crunch and finding it more reliable. And finally, because of the way it's much easier to test something like this than using the MapReduce API, we find that jobs that didn't have any tests at all now have tests, which is a great improvement. We actually have some confidence both in our existing old logic and when people are writing new stuff that it might work. So for the future, I mean, Crunch is a bit of a strange case here because it's a relatively new API in the last couple of years or so to work on a relatively old technology that most people consider towards the end of life. From our experience, despite its 0. version number, the version numbers of Crunch are extremely conservative. I would consider it's been really stable for 4 or 5 versions at least now. And it's feature complete, it's stable, it works. We're using it really happily as a pragmatic way to keep writing MapReduce code that does the things that we need to do every day. We're really excited about the Apache Beam project. I'm hoping to hear more about that. I think there's a couple of talks about it at the rest of this conference, which is actually based on the same paper that the Crunch API was originally based on. So the Crunch API was based on this Flume Java paper that came out of Google, and Apache Beam is the open source version of the Google Dataflow API, which is also an evolution of the Flume Java paper. So it seems that all of these technologies are kind of converging on the same API and certainly the same approach to programming. So with Beam in the pipeline, we're not worried at all about writing Crunch code. We don't think that this is a waste of time to do because the path from Crunch to Beam or Spark or any of the other technologies should be relatively simple. The programming model is the same. The way you have to decompose your programs is the same. Beam is getting a lot of traction. We're excited about that, of course, but we won't be able to use it probably until this time next year. And I've even considered, I'm not sure I'll do this or not, but you could, I was discussing last night at the speaker's dinner, maybe we could write a Beam runner for Crunch for MapReduce, so you can continue to run your your Beam applications on MapReduce via Crunch. But that sounds a little bit like pipeline inception, so I'm not sure if that's a good idea or not. It might happen. Oh, I made a slide about that. OK. Yeah, so in summary, MapReduce isn't going away soon, much as we'd like it to and much as the hype would tell us it is. There's a lot of investment and everything that's gone into that, and it's still quite a good fit for a lot of problems. So Crunch is a really pragmatic way to keep working with it and not be so frustrated. Java 8 has been a really great improvement for functional programming. It stops everyone from having to jump at Scala immediately if they have some kind of vaguely functional need. We're finding it actually, Scala is such a big and complex language that if we can keep people on Java 8 rather than reaching for Scala, then we'll save ourselves a lot of complexity in the long term. So we're really happy to be on Java 8, and using crunch-lambda and Java 8, it ties all the concepts together and makes us more productive data engineers. So if you want to learn more about Crunch, a good place to start is crunch.apache.org. The user guide for Crunch is really complete. I haven't yet got around to writing the user guide for crunch-lambda, but the Java docs are really complete. So if you go to the Java docs for Crunch, look up the Lambda class, and it's got lots of examples and information there. If you're interested in the use cases I presented from SoundCloud, I've written a long-form blog post on the SoundCloud developer blog about those two examples. So if you go to developers.soundcloud.com/blog, you can read about them. If you want to read more about crunch-lambda and also general topics that I'm writing about Java and modern Java styles, that's my blog at radicaljava.com. And if you want to read these slides again because you missed something, they're up on tinyurl.com/bbuzzcrunch. And that's it. I've got a new album out last month, so check it out if you're interested. I've got time for a little bit of Q&A.
Great. Thanks a ton, David, for the intriguing talk. If anyone of you have any questions, please feel free to raise your hand. I'll just quickly run across. Any questions? Any thoughts to add? We are good? All right.
Can't let me off the hook like that. We got one at the back.
Oh, cool. Please introduce yourself.
Hi, Matthias Anderson. I was just wondering, are you happy working with your Java 8 lambdas? Do your compiler, no, not your compiler, but do you use Eclipse which has type notations that is used in, or do you have any problems with typing for it in the streams?
I'm using IntelliJ most of the time, and I don't really have any problems. It's a bit confusing because sometimes, like for the crunch things, you put the type information, like you have your lambda expression, then you have an indicator of the type, and sometimes I find myself I have to fill in the type thing first, because then I'll get the autocomplete on the lambda expression. So there's a couple of little idiosyncrasies like that, because it can't figure out that no matter what I put in the second part, it's still going to be the same input. But apart from that, I haven't really had any problems with IntelliJ.
Any more questions? All right. So thank you, David, again.
Feel free to come and ask me afterwards if you have any more questions.